are going to look at the stoichiometric calculations that we've been practicing in class, and relate those to the actual terminology that we just started looking at and how that relates to the reactions that are done in the laboratory. In order to do that, I'm going to quickly review a problem similar to the s'mores. So if we were to say that we're going to make a peanut butter and jelly sandwich, excuse me, or as many peanut butter and jelly sandwiches as we can, first of all, we need to look at what ingredients we have available to us. So those are listed here. We have 4 slices of bread, 1 jar of peanut butter, and a half a jar of jelly. Now, if we were to say that we're going to make as many peanut butter and jelly sandwiches as possible, we're going to look at this and we're going to say, well, we can make 2 sandwiches total because after 2 sandwiches, we run out of bread, meaning our bread is the limiting reactant. It's the thing that stops us from making any more product. With that being said, that means our other reactants, in this case peanut butter and jelly, are in excess, meaning we have leftovers of those. So if we were to take that and come up with some actual definitions for limiting reactants, we know that limiting reactants will be completely used up in the reaction. These are the things that we are going to run out of in the reaction, and it is what determines the amount of product that can be formed. Now, these are typically more expensive ingredients because we don't want to waste them. So we want those to be our limiting reactant, so that we don't actually have extra of those and it just goes to waste. Now, be careful with the word expensive. That can mean that it costs the most, but it can also be more time consuming to make as opposed to buy. So it kind of depends on what you're looking for as to what the word expensive means. To go the opposite end of the spectrum, excess reactants are reactants that you have extra of. So I remember this because extra and excess both have the EX at the beginning. These are the reactants that you have leftovers of when the reaction is completely finished or once all of your product has been made. These reactants are typically cheaper and or easier to recycle and reuse again. Anytime you have to do a limiting reactant practice problem, there are 3 major steps to follow. The first is to write a balanced equation. The second is to then calculate the amount of product that can be formed. This is for each reactant, so that's key. So you'll have to do multiple unit analysis steps or conversion steps in this type of problem. And then once you have your unit analysis conversions finished, you need to look at the smallest or smaller of the answers, and that tells you 2 things. It'll tell you which reactant is limiting, and it'll also tell you the amount of product that you end up making. So to look at an example, if we say that we have 75 grams of zinc reacting with 75 grams of hydrochloric acid, then we need to identify the limiting and the excess reactants, as well as determine how many grams of hydrogen are actually being formed. So I have an equation down here. It is balanced, so if you don't have a coefficient in front of a substance, you assume that there is a 1 there. I have it on this next slide as well, so I'm going to switch slides here. Here's your balanced equation again. Now I'm going to organize myself just a little bit and say, okay, I'm going to start with 75 grams of zinc. I also have been given 75 grams of hydrochloric acid, and I need to figure out how many grams of hydrogen are going to be produced. Now, the amount of zinc chloride does not matter. It's in there. It is actually produced in this reaction. However, I don't care about it for this particular problem because it's not asked about at all. So I'm going to start. I've done step 1. I have my balanced equation written down. Step 2 is to do my unit analysis conversions. So I'm going to start with one of the 75s. You can start with either one. I'm just going to do the first one. So I have 75 grams of zinc, and I need to get to my mass of hydrogen. Now, I know that I don't want my grams of zinc, so I'm going to cancel those out. When I go ahead and cancel those out, I need to put them on the bottom. And then I need to ask myself, where do you get your mass number from? We should know by now that our mass number comes from the periodic table. So I need to look at the periodic table for element number 30, which is zinc, and I see that it has a mass number of 65.39. So I'm going to put that in my number spot in front of grams, and then I'm going to always put 1 mole of zinc on, or 1 mole on the opposite side of grams. Note that this does not come from the equation, it just is always 1 because I have that many grams in 1 mole of my element. So my grams of zinc have canceled out, and I'm left with moles of zinc. I do not want moles of zinc, so I need to cancel it out. So I'm going to put it on the bottom of my fraction. And then if I'm stuck, this is where most of my students get stuck, and they're like, I don't know where to go from here. If you don't know where to go, because it's not grams and moles on opposite sides of the conversion, then you need to put your goal on the top. So I'm going to put grams of H2. If I look at this, that means that I have, or I'm changing from zinc to hydrogen and from moles to grams. Now I'm only allowed to change one thing at a time. I cannot change my bottom, I can't change the bottom unit down here because I want it to cancel with what's on the top over here. So that means I have to change something out of the top. So I'm going to take grams and make it mole because I want to get into hydrogen, but I can't get to grams yet. So I'm going to leave it as hydrogen, but go to moles. Now, when I have moles on top of moles, that means I have a molar ratio, and I need to get that number from the equation, or both of those numbers rather. So I need to look at what coefficient is in front of hydrogen over here and what coefficient is in front of zinc. They're both 1s in this case, so I have a 1-to-1 ratio. They're not always going to be 1, however, so be careful with that and make sure you look at your equation every time. Right now I'm stuck with moles of hydrogen. I do not want that, so I'm going to put it on the bottom of my fraction so I can cancel it out. And then I'm going to put grams of hydrogen up on top. Right now I'm keeping hydrogen the same, but I'm changing my units from moles to grams, and that is okay. So it's only changing one thing at a time. Again, if I'm looking for the mass or grams of something, I need to get that from the periodic table. So if I look at hydrogen on the periodic table, I have 1.0079. Now, that is only 1 hydrogen, so I need 2 hydrogens because it's H2. So I'm going to multiply that by 2 and get about 2.016. And again, I always have 1 mole on the opposite side of grams. Once I have that completed, then I can go ahead and actually solve by multiplying the numbers on the top and dividing the numbers down on the bottom. When I calculate that, I end up with a mass of hydrogen that is 2.3. Now 2.3 is rounded, but I'm rounding to 2 digits because I started with 2 digits. So this is my first answer. My second answer, this is going to go a little bit faster because I'm not going to explain every step of the way, but I'm going to start with 75 grams of hydrochloric acid, and I want to get to grams of hydrogen. Now you need to go to the same goal as before so that you can still compare your answers. So we know that our mass of hydrochloric acid is going to come from the periodic table if we look up above. So if I add up hydrogen and chlorine on the periodic table, I have 63.46, and I always have 1 mole on the opposite side of grams. Then my grams have canceled. This is moles of HCl, so I don't want that anymore, so I need to cancel it by putting it on the bottom. Once I put that on the bottom, if I'm stuck, I can put my goal over here, and then I say, oops, can't really do that because I can't go from moles to grams and HCl to H2, so instead of going to grams, I'm going to change that to mole. Again, when I have moles on top of moles, I have my molar ratio, and I get that from my balanced equation. So in front of hydrogen, over here, I have a 1. In front of HCl, over here, I have a 2. So then my moles of HCl cancel out. I'm left with moles of hydrogen. I need moles of hydrogen to cancel. And if you look at this last step, it should look familiar to you because it's the same as the one up above because we're going to the same goal, so we should end up with the same last step. So I can literally take my mass of hydrogen from above and put it down here in this problem. My moles of hydrogen cancel out and I'm left with grams of hydrogen. Now if I go ahead and I plug this into my calculator, I am again going to multiply the numbers on the top and divide by all of the numbers on the bottom. Don't forget that 2 in the molar ratio because we didn't have that last time, so be careful with that. Now when you do this and you actually calculate this, you end up with 2.069, but we're going to round to 2 digits again just because we started with 2 digits, and so we have 2.1. Now, if you look at your 3 steps to a limiting reactant problem, we've already done a lot of work. We've done step 1, we've done step 2. Step 3 is very basic. All you're doing is labeling things. So you need to look at the smaller of the 2 answers. So in this case, it's 2.1. And this tells you 2 things. It tells you what reactant is limiting, and it tells you how much product is formed. Now, this 2.1 is not the limiting reactant because it's talking about grams of hydrogen. If you look up here, hydrogen is on the right-hand side of your equation, meaning it's not a reactant. So it can't be the limiting reactant, which means this is the actual amount of product that is formed from the reaction between 75 grams of each reactant. Now, our reactants are on the left-hand side of our equation, so we have HCl and we have zinc. We need to figure out which one is limiting. This 2.1 grams that we just found tells us that I can make 2.1 grams of hydrogen if I use all of my hydrochloric acid, which means it's gone after 2.1 grams. So there's no possible way that I can make 2.3 grams of hydrogen because after 2.1 I'm out of HCl. So that means that this is my limiting reactant, which then means that zinc is going to be the reactant in excess. Now, you need to make sure that when you do any limiting reactant problem, you're going to have 3 things labeled. You're going to have your amount of product that you form, your limiting reactant, and your excess reactant. Make sure you label each and every one of those for your limiting reactant practice problems. So, let me know if you have any questions over this video. Feel free to watch it again as a refresher or even just later before a test or a quiz. Go ahead, of course, ask me questions in class, and good luck, guys.